time zone you are using. Mr. Mota is my name. I will be taking you matrix algebra 1. I've studied mathematics for a while, so it's a pleasure meeting with you. So I felt all the knowledges I have in the field of mathematics for posterity's sake, I intend to impart it with those of you who are studying mathematics or doing any field that has to do with mathematics or probably engineering. As you all are aware, we're in a digital world. Most of the things you see that we use practically, they are connected to the field of mathematics. This matrix that I'll be breaking down and explaining to you, that is what Google Map uses. Is to give you several options and then you choose the most efficient one. So if you are going to be a programmer later in life, you need to have the basics, the basic knowledge about how these things work so that you can be a good and efficient programmer. So I'll be taking you matrix algebra. Other courses will be coming up, right, in the area of mathematics and probably statistics as well for researchers, so that we can be able to at least impact our generation. So this morning we are looking at the fundamentals of matrix algebra. That is, we are combining matrix with linear algebra. So these are the basics. If you are able to get the foundations of what we are doing and then get ready, as we build on it, you'll be very, very good when it comes to matrix algebra. So this matrix algebra one. Some of you may have an idea of matrices already. Now, the formula Aij is equals to A plus I plus J for 1 is less than or equal to I, less than or equals to 3, and then 1 less than equals to J or less than equals to 4. So that defines a 3 by 4 matrix. In other words, we are saying A, capital A, is equals to Aij, namely. So what you have now is a 3 by 4 matrix. Are you getting the point now? A 3 by 4 matrix A is equals to capital A, and you have these equations. Just follow me, you'll be able to get it as we move along. So when you have A34, you are like also saying you have ARC. In other words, this 3 is representing row, and this 4 is representing column. So that is one of the easiest ways for you to get it. This is representing row, this is representing column. So what this mathematical jargon that we just wrote, what is it representing? It's representing that a dimension A is having 3 rows. That is, this is 1 row, this is 2 row, this is 3 row. And then having how many columns? Having 4 columns. This is 1, 2, 3, 4. That's why I told us that what I just broke down now is very easy for you to follow. So if you are not even in the field of mathematics, or maybe you are undergraduate and you're having certain issues with this field, I'd like you to settle down, because as I take it from the basics, you'll be able to understand what it's all about. Right, so matrix A, which is 3 by 4, and I told you that 3 now represents row, and this 4 represents column, is equals to capital A, and then we have an example of what it's all about. So you have 3 rows, if you move that way, and then what happens? You have columns. So for you to even make it easier for you, right, you look at the rows as the horizontal line, although sometimes it can be turned anyhow, but the columns are vertical as far as this diagram is concerned. So let's move further, because we're going to be brief. I will give you little by little so that you can be able to digest it. Now let's look at types of matrix. We have the null matrix. There are several of them. We're going to look at all, but this is just the introductory stage. Types of matrix. Number one, we have the null matrix. What is it all about? This is the kind of matrix all of whose components are zero. It is denoted by zero. Can you see all the components in this dimensional matrix? Can you see all the components? 0, 0, 0, 0, 0, 0. And it's what? It's a 2 by 3. What do we mean? You have 2 rows. And then how many columns? 1, 2, 3. That's why you have 2 by 3 matrix. And it is referred to as a null matrix, because all the components are 0. Number 2, you have the square matrix. This kind of matrix is where you have, I've explained what the row and the column is to you. So when you say 3 by 4, you say 5 by 4. The first is the row, the second one is the column. So where you have the square matrix, that's another type of matrix. The square matrix is where you have the rows, all the rows is equal to the column. And this is an example. And this is an example where you have all the components. They have equal rows. They have equal column. And see, 1, 2, 3, 5, 5, 6, 7, 8, 9. So how many rows are you having? 1, 2, 3. And how many columns? 1, 2, 3. So it's a 3 by 3 matrix, and it's referred to as what? Square matrix. What else do we have? We have a diagonal matrix. Diagonal matrix is a square matrix with all the diagonal elements 0. It's a square matrix with all the diagonal elements 0, which is very simple for you to see. Can you see all the diagonal elements? We have 7. See the diagonal elements. We have 7, 0, 0, 0. Right? The last two components of the first row is 0. Right? The second row, the first and the last component is 0. Are you getting the point? And when you come to the last row, which is row 3, if you would like it, you have 0, 0, and then you have 6. So this is denoted by 7, 5, 6. So this is referred to as a diagonal matrix. Very simple. Where you have a single line of figures and all the diagonals are 0. So this video is always there. You look at it again. Is that okay? So next time we'll continue with types of matrix. My intention is to make this field easy for undergraduates, even down to 500 level, who are having issues with linear algebra, as it had to do with matrix. So this is enough for today, but I'd like you to go through it again. We are building on it. Right? We're going to look at all these types. All these types of matrix you are seeing will come up in much more complicated figures by the time we begin to go deeper and deeper into the full linear algebra. But for now, just take this. Right? The next time we'll also take other types. We have so many of them. You know, with this improvement in knowledge and all of that, I think we are supposed to be up to 20 or more. Right? But let's take these 3 today. Alright, so let's quickly review what we looked at. I was just trying to give an idea of what the matrix is. And I said the formula AIJ is equals to I plus J. For 1 is less than I is equals to less than equal to 3, comma, then 1 less than j less than equals to 3. So this formula is a dimensional matrix. Dimensional matrix Aij. Are you getting the point? Or you can say matrix A of order Aij. Right? So it defines a 3 by 4 matrix. The same is equals to A. Is equals to A of the Aij, namely. Are you getting the point now? 3 by 4 is a 3 by 4 matrix, which is this. And I explained earlier, what do I mean? It's row, the first figure here represents row, the 4 here represents column. That is order, row, right, by column. That is what it's all about. So you have how many rows? This is the first row, the second row, the third row. That's why you have 3. That's why you have order 3. Then by 4, you have how many? How many columns? 1, 2, 3, 4. So it's very simple. Anybody can make. With my own method of teaching, I will ensure that everybody understands the basics, so that you don't just struggle in school or in higher institution or during your A levels. So types of matrix we have been. I'm just giving you the foundation. By the time you know all the types of matrix, as we go deeper and deeper, it will be very easy for you to define and solve when you have questions. And I said the null matrix, the matrix of all whose components are 0, is denoted by 0, is referred to as the null matrix. So you have the components inside the dimension 0, 0, 0, 0, 0, 2 by 3 is referred to as null matrix. And we said what? Number 2, the square matrix, is when you have the number of rows equals to the number of columns, denoted by n or the n matrix. So when you look at these figures carefully, how many rows do we have? 1, 2, 3. How many columns do we have? 1, 2, 3. So it's a 3 by 3 matrix, a rectangle square matrix. So that when we begin to use these terms, it will be very easy for you to understand. And then number 3, we have the diagonal matrix. It's a square matrix with all the diagonal elements 0. Underline it with a square matrix in case I give you questions. So you see 7, 5, 6. All other sides are 0. See this one. The first digit starts with 7, then you have 0, 0, and all of that. So check this line, right? This side 0, the other side 0. The diagonal elements are 0. So it's denoted by dimension 7, 5, 6. That is that. So go through it. We'll add more types as we move on. Thank you.